Okay, so here we are today again, continuing our series on calculus, and today we are going to be looking at the quotient rule when differentiating. Prior to this video, we addressed looking at the power rule, and we look also at the product rule and chain rule. Please go back and look at those rules if you need a refresher or even how to apply those concepts. Today we're going to move on to the quotient rule. The quotient rule for today, or to our objective for today, basically we're going to be looking at how to differentiate functions using the quotient rule, and more importantly, we have to be able to identify when does a function calls for the quotient rule when differentiating. Good. So firstly, let's look at the rule. And the quotient rule goes like this. So if we have a function over a function, as quotient implies, some division have to be taking place. So if we have f of x divided by g of x, granted that f of x is a function and g of x is a function, all we need to do when we find the first derivative or when we are differentiating is look at this little formula we have at the bottom here. So this is basically the golden formula. I'll explain it and I will write it over again in a different way that makes me remember even easier. So all we do here basically is we square the bottom function, so which is g of x. Let's refer to these two functions at the top here, f of x, g of x. So g of x, which is the function below, whatever we have as a function, we will square that whole function, and then at the top we have the given function, the original function, and we're multiplying that by the first derivative of the top function. Then we are subtracting now the top function by the first derivative of the bottom function. And that is basically in a nutshell. Let us see if we could use it in a different scenario. So I usually like to use this example. This kind of makes it a little easier for me. I don't know if it will help you, but let's see. So we have f of x is equal to, let's say, u over v. You will also see this online. There are many references on this online. U over v. So we have v as the bottom function and u as the top function. So if I have to differentiate that now, I will go like this. U prime of x. So this is the first derivative now. Look at what the rule says. So the bottom function, we're squaring it. So that means the v, whatever function v is, will be squaring the v. And then we have that same v at the top, and we'll be multiplying that by the first derivative of the top function. So that is v multiplied by u prime. So the bottom function multiplied by the first derivative of the top function. And then you take away the top function, so that will be u, and then you multiply that by the first derivative of the bottom function. So that will be v prime. And it is as easy as this. So I don't know if this will simplify your life. So if we have a scenario of f of x of u over v, again, v will always be the bottom, so we square that. Whatever is below, let's look at it that way, we square it. Then whatever we have below, we put it at the top, and we're multiplying that by the first derivative of the numerator, if I may use my terms. And then you subtract that by the numerator, which would be u, and you multiply that by the first derivative of the bottom, which is the denominator. This is one way to look at it. And another way I've seen students learning it too is also by using the acronym, not acronym, what do you call that? Anecdote. Is that anecdote? Can't remember, but it's a nice phrase. So some persons say low D high. Low D high, I wouldn't write it because of my writing skills right now. But low D high minus high D low and low squared. All this is saying, is like low. Low is the bottom. So low D high. Low differentiate high. So low differentiate the numerator. High will be the top numerator. Minus now high D low. Meaning high we refer to the numerator, D as differentiate, low, the denominator. And then we have low square. If you write it, it will be a lot easier to recall. So high the low the high. Low the high the low, and low squared. Good. So again, you could play around with it. There are many ways to learn them, but I usually like to recall this u over v, and I remember the placement. V squared, then v multiplied by u prime minus u prime, u multiplied by v prime, and all that over v squared. So let's see if we could get some practice in. Let's get some practice time. Again, remember, we know that we could use the quotient rule as long as we have a function divided by a function. And in these two examples, that is exactly what is happening here. 6x squared is a function, and that, something wrong here. I have y is equal to x is equal to this. Anyway, don't let that thought here. This is supposed to be f of x. I'm not sure we end up like this. Anyway, so we have 6x squared. This is a function, and over 2 minus x, this is also a function. One is a quadratic, the one at the top, the one at the bottom is a linear. And here we have another function, number 2, y is equal to 3x plus 4x to the squared, 4x to the fourth, divided by 2x cubed plus 1, a function over a function. So again, if you think you grasp the concept, you could pause the video here and see if you could do it, attempt them on your own. If not, let's do them together. So let's try the first one first. So I have y is equal to 6x, ignore this x here. So we have y is equal to 6x squared over 2 minus x. And again, I could differentiate off the bat. So how do I do this? Y prime is equal to, I'll start from the bottom because the bottom is very easy to figure out. So remember, v squared, so that simply means 2 minus x all squared. And this is applying the quotient rule, right? So 2 minus x, let me write this x a little better. 2 minus x all squared, that's the bottom. And then we have on top now, we have the v, which is the bottom. So 2 minus x, we leave it just like that. And we multiply the bottom by the first derivative of the top, which in this case will be, applying the power rule there, we have 12x. Good? So that's that part there. Minus now, we have the top, so the function at the top. So that will be 6x squared. We don't interfere with it there now. And we multiply that now by the first derivative of the bottom function, in which this case will just give us -1. Easy does it. And that is the end of the differentiation element. And from here now, we just do some algebra to clean it up. Let's see if we could clean it up a little. Let's see how far we could go. So from here now, I have equal. I could distribute this 12x into this 2 minus x. If I do that, I will end up with 24x. Yes, 24x minus 12x squared. Yes, 24. So that what I did here is 12 by 2, in case we cannot see it, and 12 by x. Good. So 12 by 2, that gives me 24x, and 12 by x here, -x, that gives me -12x squared. 12 by 1 is 12, and x by x is x squared. Good. Minus, or rather, let me change that one time, plus -1 by 6x squared will give me -6x squared. And -6x squared by this minus sign in front here will give me +6x squared. Yes? And all that is still over what we had at the bottom, wasn't interfered with. So that's 2x all squared. Right? That's what we have. And I think there's one more cleanup phrase that we could do here. So here we could actually how should I say, we could compute the 12x squared with the 6x squared. And again, because it's negative, well, usually I say I prefer the highest degree first and we come down the line. But at the same time, I don't like a negative popping up at the front. So I will make an exception here, a personal exception here. So I have now 24, and this is personal preference. This is not necessarily standard how it's supposed to be. Minus 6x squared. Right? 24x is the 24x here. This remains as it is. But minus 12x squared plus 6x squared will actually give us -6x squared. If you have any dispute there, we just have to review the laws of indices and know what happens when we are adding, subtracting, multiplying, adding different numbers with different signs. I wonder if that falls under indices itself. I think that's more algebra. Minus x. I have to know the signs. Right? And this is as far as we could go. So the answer is right here. Some persons I know, sometimes they think of expanding this here to the bottom here. 2 minus x all squared, you just multiply 2 minus x times 2 minus x, and then you end up with a quadratic formula, or a quadratic expression actually. But you don't have to go that way unless, of course, we ask to maybe identify the roots, or if we ask to find the limits, or perhaps if they want us to know if this is continuous or discontinuous, or if we perhaps even finding the gradient at a given point. Those will be grounds in which we want to expand this and go as low as we could. But if not asked and we just ask to differentiate, we just leave it at this. This is it. There's no need to hurt our head further. This is as low as we could go, and this will be our y prime. Good. No need to take it any further, and please don't even consider canceling this x with this bottom x or this x with this bottom x. That's a no-no. That's out of the question. Tertiary students, that's out of the question, right? Okay, so let's go on to the next one. Question number 2, last one. And again, here we have another function being divided by another function, and this again creates grounds to apply the quotient rule. So how do I go about doing this one? Again, apply the same rule. It will take some getting used to, but once you understand the quotient rule, to be honest, it's one of the easiest rule. I think this is as easy as a power rule. The only thing is that what makes the quotient rule a little difficult sometimes is when we have to perform the algebra. Yeah, sometimes it does get messy and complicated, but that has nothing to do with the quotient rule. Applying the quotient rule is very straightforward. So here, let's see what we have. So again, I'll start at the bottom because the bottom is very easy to identify. So we have 2x cubed plus 1, and according to the quotient rule, we just have to square the denominator. So that will be 2x cubed minus, plus 1 all squared. Good. So that's the first part. And then we have the denominator. So that's the same 2x cubed. So we have 2x cubed plus 1. That stays just so. And we multiply that by the first derivative of the top. The first derivative of the top, again, is 3x plus 4x squared. When I find the first derivative there, I will end up with what? No, not x, with 3. The x will disappear. The x will disappear, power rule. So that will leave us with 3 plus 16x. 3 plus 16x cubed. Power rule. The 4 goes in front, and then we take away 1. Right? So that is how we apply our power rule. And we subtract now the top function, which will be in this case 3x, and this time it stays just like that, we don't interfere with it. 3x plus 4x to the 4th, and that is multiplied by the first derivative of the bottom, which in this case will simply be 6x squared. Yes, remember this here, 6x squared, the 3 goes by the 2, 3 times 2 is 6, and we minus 1 from the 3, that gives us the power of 2. And from our first video, when we look at the power rule, we know that once we differentiate a constant or a variable, it becomes 0. So there's no need to put 6x squared plus 0. And this here is the end. This is the end of the differentiation. And again, as I said, that's the easy part. Now the tough part comes when we have to clean up sometimes. So let us see if we could clean up here. Here we have a binomial multiplied by a binomial. So remember, just like high school, again, I always like to make that reference. We always multiply everything throughout. So we have to do the 3 by that, then the 3 by this, and then we do the 6 by that. Oh, that looks confusing, and the 16 by this. So basically, that is what is happening here. We're going to do that and see what we end up with. And then we also have the same thing over here, but here we have a monomial with a binomial. So this will make it a little easier. So let's do that and see what we end up with. So the first part here, 3 times 2x cubed, that would give me 6x cubed plus 3. 3 times 1 is 3 plus, now I'm going to the 16. 16 cubed times 2x cubed, that will give me what? 32. Oh Lord, y'all will really have to forgive me for my writing until I get this part to write on. So 32x cubed No, not cube. The powers are added. Keep the base, you add the power. So this will be 32x to the 6. A cube times a cube, that will be 6. And then 16 times 1, that will give us the same 16x cube, right? Minus on the other side, we have, and I'm distributing, remember I have to distribute the minus sign. So minus, that will give me what? 18x cube. 18x cube. And how did I get that? This times this, and then we do this times this. So 18x cubed, that will be 6x squared multiplied by 3x, and that will be minus, because I have to distribute this negative sign here, minus 24. It was x to the 4th. 6 times 4, by the way, is 24. That's why I end up with 24. 6 times 4. And x to the 4th multiplied by x squared, that will give me x to the 6th. Yes, x to the 6th. And all this is over the bottom. I haven't done anything to the denominator. So that will give me 2x cubed plus 1 all squared. Yep, easy does it. And from here, again, we just have to do some cleaning up. Let's do some clean up. Time to clean up. So we're cleaning up the denominator. And how do I go about that? Again, I just look for like terms. And by like terms, I'm looking for terms that have similar x indices or x power. And again, I like to start from the highest to the lowest. So if I'm looking here, firstly, I notice that we have this x here. This is the highest degree I'm seeing here, 32x to the 6 with 24x to the 6, right? This 32x is positive, the 24x to the 6 is negative. So I have to subtract 32 from 24. So let me see if I could start writing my answer here. I'll do it part by part, so hopefully I don't lose you along the way. So here we have 32 minus 24, and that will give me 8x to the 6, right? So that takes care of the highest degree. After 6, I am seeing what? 3. 3 is the next highest degree. I have 6x cubed. I'm seeing 16x cubed. And I'm seeing, let me put it in another color. So we have 6x cubed. I'm seeing 16x cubed. And I'm seeing 18x cubed. So we could simplify that. So that is, let's see, 6 plus 16, that will be 22. And then 22 minus 18, that should give me positive 4x. Positive 4x cube. So that takes care of the highest cube there now, or all the cube. There is no x squared, there is no x, so then that just gives us the last one here to be this 3 here, standing all by itself. So we just put that 3 there as a constant. Yep, and that worked out pretty neatly, and that will all be over our denominator, which hasn't been interfered with. Cube plus 1 all squared. Yes, people, and this will be our y prime. As messy as it was, look at how nice it worked out. So again, once you understand the quotient rule, is a matter of just knowing who to differentiate, who's getting squared, and who is being subtracted from what. And from that is just a game of algebra, of cleaning up, multiplying, expanding brackets, see what goes with what. And you know, it's that simple. In time to come, of course, or in our next video, we're going to be looking at some implicit differentiation before we go on to logarithmic differentiation. And what I'm looking forward to the most at the ending of all this is looking at the application of the derivative, the differentiation. So right now we're just looking at the rules, but why do we differentiate? Why do we have to apply these rules? So we're going to look at those things when we reach in that application video. So this will be the ending of today's video. So again, as always, feel free to like, share, and subscribe so that you'll get more videos like this. And until then, see you all again. Take care.